An equation that contains a variable, usually x, in the denominator is a rational equation. The steps to solve are 1. Identify the domain restrictions. 2. Multiply both sides by the LCD, the least common denominator. Step 3. Solve for x in the resulting equation. And step 4. Check your answer. In our first example, we want to find the domain restriction first. So I'm going to do that off to the side. The domain restriction is what x cannot be. Remember, you can't divide by 0. So if we set this denominator equal to 0, we see that x cannot be 0. So just make a note of that. Sometimes it affects our answer, sometimes it doesn't, but it's always a good idea to do that step first. Next, we want to look for the LCD, the least common denominator. The smallest number that is a multiple of 3 and 6 is 6. It's the smallest number that both 3 and 6 divide into evenly. And since x is also part of the denominators, we want to include that as our LCD. What we're going to do now is we're going to multiply every term by the LCD. So we have 6x times 3 over x minus 6x times 1/3 equals 6x times 1 over 6. And if it helps you, you can put 6x over 1, because really we're just making it a fraction. We're multiplying by a fraction. Remember that before you multiply fractions, we can reduce this. So you want to ask, what do we have in common in the top and the bottom? And in this case, there's an x in common. So x in the denominator will go away to just 1. And in the top, the x cancels and you're left with just a 6. In our next term, 3 goes into itself once and 3 goes into 6 2 times. The x is still there. And on the far right, 6 goes into itself once and 6 goes into the 6x 1 time, but the x does not go away. Only the 6's reduce away. Now we're left with 6 times 3 minus 2x times 1 equals x times 1. We can simplify that. 18 minus 2x equals x. From here, we can add 2x to both sides. (18) is equal to 3x. Finally, we divide by 3. And we get x is equal to 6. Make sure that the value you find for x is not a restricted value. And in this case, it's not. 0 is restricted, but 6 is good. You can always check your answer using the calculator. I'm going to go to y equals, and I'll type in 3 divided by x minus 1 divided by 3. And I'll do that on the left side, and on the right side, I'm going to put in y2, 1 divided by 6. And graph. We're looking for where they intersect, and it looks like they're intersecting over here. To find that, we'll hit second, trace, and number 5 is what we're looking for. Notice it's on the first curve. You may have to scroll a little bit to find it. There it is. We want to get close to what we think is the answer. It looks like it's crossing around 6. Hit enter, it'll automatically jump to the second curve. Again, we can move that cursor around if we want to. Hit enter, enter, and it spits out the coordinate where those intersections are happening. Remember that we want the x value, which is 6, which confirms our algebra. In the next example, we first want to look for any domain restrictions. So we'll make a note of that off to the side. remember, to find a domain restriction, we set each denominator that has an x in it equal to 0. So we have x plus 4, set it equal to 0, and solve. We get x cannot be negative 4. We'll do the same thing with the other denominator, x plus 6, set it equal to 0, and solve. We get that x cannot be negative 6. So these are the two domain restrictions. Up next, we'll look for the LCD. The first denominator is x plus 4. The second denominator is x plus 6. Next, we want to multiply by the LCD. We'll multiply every term by that LCD. We have negative 4 over x plus 4. Set that equal to, again, we need the LCD. That is times negative 3 over x plus 6. From here, we'll go through and see if anything reduces. Look at the numerator and denominator and see if anything will cancel out. X plus 4 occurs in the top and the bottom on the left side, and on the right side, x plus 6 we can reduce. So we're left with x plus 6 times negative 4 equals x plus 4 times negative 3. Distribute to remove the parentheses. Negative 4x minus 24 is equal to negative 3x minus 12. At this point, we want to move all the terms that contain a variable to one side. I like the left, and then terms that do not contain a variable to the opposite side. We're going to add 3x to both sides and add 24 to both sides. This will make the x's appear on the left and then the constants on the right. We have negative x equals 12, divide by negative 1, and x is negative 12. Notice that negative 12 is not a restricted value. You still need to make sure that the answer that we get for x is not restricted. We can double check using the calculator. Under y1, first we need to clear, and then beside y1 we'll type in the fraction negative 4 divided by, since the denominator contains more than one term, we do need to put it in parentheses, x plus 4. And under y2, or beside y2, we'll type in the right side. And just as a reminder, if you want the pretty fractions, we can hit alpha y equals number 1. And this is just an alternate way to type in the fraction. This way we don't need the parentheses. So we have negative 3 over x plus 6. And then when we graph, we're looking for where they intersect. It looks like they may intersect over here, but it doesn't. We know what we think the answer is, negative 12. So let's play around with our window and see if we can get negative 12 to appear. We need to make our x min smaller. Do negative 20 for that x min and go back to the graph. And now second trace will take us to the calculate option. We want number 5. First curve, we'll scroll that cursor over to around negative 12, hit enter. It's going to automatically jump to the second curve, hit enter, enter, and we get the coordinate of intersection, negative 12, 1/2. And the x value is what we're looking for. Negative 12 confirms our answer is good. Notice in this example, one of the denominators on the far right is a quadratic. To help us get started, it may be best to factor that first. To factor that, you want to find two numbers that multiply to negative 10 and add to 3. That is positive 5 and minus 2. Up next, we'll find those domain restrictions. In order to do that, set each denominator equal to 0. Up first, x minus 2 equals 0. That means x cannot be positive 2. And x plus 5 equals 0. That means x cannot be negative 5. Notice that the first two factors are the same that occur down here, so there's no extra restricted values caused by these two. They're the same as the previous two restrictions. Next, we'll multiply by the LCD. The LCD is x plus 5 and x minus 2. We want to multiply every term in the original equation by that LCD. X plus 5, x minus 2, times 4 over x minus 2. And that's equal to x plus 5 times x minus 2 times negative 3 over x plus 5 plus, again, the LCD, x plus 5, x minus 2 times 7 over, I'm going to use the factored version, x plus 5 times x minus 2. Now we can go through and reduce any factors that occur in the numerator and denominator. In the first term, notice x minus 2 is in the top and the bottom, so let's reduce that away. In the second term, x plus 5 will cancel, and then on the far right, both factors go away. This will leave us with x plus 5 times 4 equals x minus 2 times negative 3 plus 7. From here, we will distribute to remove the parentheses. 4x plus 20 equals negative 3x plus 6 plus 7. Combine like terms on the right side. We'll get negative 3x plus 13. At this point, we want to move all the x's to the left. We'll add 3x. And move the constants to the right. So subtract 20. 7x equals negative 7. Divide by 7. And we get x equals negative 1. Notice that's not a restricted value. We can double check in the calculator. Go to y equals, clear anything that may already be there, and let's type in the left side first, 4 divided by x minus 2. Notice that the denominator has more than one term in it, so it needs to be in parentheses. Whenever you're entering something into the calculator kind of nasty like this, it's always a good idea to go back and double check. Make sure you don't have any typos. It's easy to do when you're dealing with messy equations. Now we'll graph. And it looks like we're intersecting at negative 1. That confirms our answer. But let's really double check. Let's go to second trace. Number 5 is intersect. It's automatically on the first curve. I'm going to scroll over close to that intersection, hit enter, 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 and it looks like we're good. -1 is the x coordinate of our intersection. So that confirms our answer is right.